What if Earth suddenly took Mars' place in the solar system? Would we become a frozen wasteland? Could humanity survive in the new deep freeze? Would Mars bloom with new life in our place or collapse under Earth's legacy? And what would happen to our moon, our climate, our oceans, and everything we thought was stable? It might sound like science fiction, but shifting Earth to Mars' orbit about 78 million kilometers farther from the Sun would transform our planet in ways we can barely imagine. And as for Mars moving inward, it would be no paradise either. Let's dive into the cosmic chaos of an orbital swap between two very different worlds. Before we continue, what do you think would happen if Earth suddenly moved that far from the Sun? Would we freeze instantly, or could humans adapt? Drop your wildest theories in the comments below. Let's see who gets close before we reach the end. When Earth shifts from its current orbit at 149.6 million kilometers to Mars' average orbital distance of 227.9 million kilometers, the first and most immediate effect would be a dramatic reduction in solar energy. Earth currently receives about 1,368 watts per square meter of solar radiation. In Mars' orbit, that figure drops to around 590 watts per square meter, less than half. This means global temperatures would plummet. Within weeks, most of the planet would begin to freeze. Tropical regions would start to resemble tundras. Mid-latitude areas would fall into permafrost. And the poles? They'd become even more alien than Antarctica, vast, dark, icy plains, where survival would require technology that doesn't yet exist. Plants would struggle or die. Photosynthesis is directly tied to light intensity. Without enough sunlight, crops would fail, forests would decay, and oxygen production would slow. Earth's lush green biosphere would turn gray, then white. As temperatures fall, so does precipitation. Rain would vanish. Snow would dominate. Weather systems would slow down dramatically because of the weakened thermal engine driving our planet's atmosphere. The result? Long, stagnant winters with little movement and no recovery. The oceans, which regulate much of Earth's climate, would begin freezing from the top down. Sea ice would expand toward the equator. Marine ecosystems would collapse. Coral reefs would die quickly. Entire food chains would disintegrate. And then there's our moon. Earth's moon would still orbit our planet, but its stabilizing influence would change. In Mars' orbit, solar gravitational pull weakens slightly, potentially increasing Earth's axial wobble. That could lead to extreme seasonal variations, even in the midst of a global freeze. Population centers would rush toward the equator to escape the cold. Massive infrastructure projects would emerge: underground cities, artificial habitats, solar concentration facilities. But without preparation, billions would face starvation, exposure, and social collapse. Power grids would fail. Fossil fuel use would surge in desperation. Atmospheric carbon dioxide might temporarily delay the freeze, but would soon become irrelevant as sunlight continued to fade. The few remaining zones of livable temperature would cluster around geothermal hotspots like Iceland, parts of the Pacific Ring of Fire, or deep sea vents. If ocean life could somehow survive, these places might become the last strongholds of biodiversity. Over time, Earth might stabilize into a colder, slower, thinner version of itself. But the transformation would come at the cost of massive extinction, collapse, and reinvention. While Earth freezes in the outer solar system, Mars is on a new path, falling inward toward Earth's former orbit. Now positioned inside the Goldilocks zone, Mars receives more sunlight than ever before. But don't expect it to suddenly sprout forests and oceans. Mars may be warmer now, but warmth alone doesn't make it Earth-like. It has deeper problems. The biggest? Mars' atmosphere. It's thin, about 1% the pressure of Earth's. Even in a warmer orbit, that's not enough to hold in heat or support life. So while surface temperatures might rise by 20 to 30 degrees Celsius on average, the planet would still be brutally cold by human standards. You might get brief water flows, maybe puddles in the warmest spots, but no oceans, no rain cycles, and no breathable air. However, there's a twist. That extra sunlight could jumpstart the process of terraforming if humanity was ready. With massive effort, we could send machines to melt polar ice caps, releasing trapped CO and thickening the atmosphere. That greenhouse effect could trap more heat, starting a slow climb toward habitability. If we added methane and other gases, the change would accelerate. Now imagine genetically modified plants grown in glass domes. These plants would exhale oxygen, thicken the atmosphere, and slowly reshape the Martian sky. Cities might rise under transparent shields. Energy would come from the sun, now far more generous. It would take decades, maybe centuries, but Mars could begin to evolve. There's still a major danger: solar radiation. Mars has no magnetic field. At this new proximity to the sun, its surface would be bombarded by harmful radiation every day. Human habitats would need shielding. Any life native or human-engineered would need protection or adaptation. And we can't forget gravity. Mars is only about 38% the gravity of Earth. Even if you could build a livable world, long-term health problems would emerge: bone loss, muscle atrophy, and possible neurological issues. Humanity would need technology, biology, or both to adapt fully. Still, if we compare, Earth in Mars' orbit becomes a frozen shell, barely sustaining life. But Mars in Earth's orbit becomes a possibility. A rough, dangerous, and engineered one, but a beginning nonetheless. So what happens in the centuries that follow? Earth becomes a deep, quiet ice world. Survival depends on geothermal energy, sealed shelters, and underground life. Mars becomes a half-warm, half-dead planet clawing its way toward revival. And humanity stands divided, one foot in the grave, the other stepping into the future. Would Earth ever be able to return to its former orbit? Could Mars become Earth 2.0 with enough time and science? Or would we lose both planets to our own bold experiment? These are the kinds of questions only time and science could answer. But let's hear from you. If you had to choose, would you survive in frozen Earth or help terraform Mars from scratch? Tell us in the comments, and don't forget to subscribe for more wild, what-if science adventures every single week.